So welcome to Unit 3, Lesson 5 on polar coordinates. And before we go into some example problems of what you'll be doing in your homework set, we need to talk about what it means to be a polar coordinate. So far you have graphed XY coordinates in a rectangular or Cartesian plane. When you graph a polar coordinate system, we do have a place called the origin, but this origin, we also now have a vocabulary word. It's called the pole. Okay, it's where the two axes meet. Next, we are going to, and often this point is denoted by the capital letter O. We are going to call this axis right here, the horizontal, our polar axis. And when we want a polar coordinate, I'm just going to pick one. I'm going to pick this right here. The purpose of a polar coordinate is when we have an XY coordinate, we get a directed distance of X and Y to get to the coordinate. But if you think about maybe how some people give directions, they just point and they say, go that way a mile or go that way so far. That's kind of what polar coordinates are about. We can define this point right here as go this way, go this direction, where that direction is a certain angle, theta. And then how far of a direction we want to go is the radius of some type of circle. So that's why this polar paper that I'm going to have plenty of, I'm sorry I got off on there, that I'll have plenty of copies in class, or you can copy your own, is going to be helpful in this particular section. So this point right here, we have theta, which is a directed angle, and we have a radius, an r, that is a directed distance. And we get to this point P, a polar coordinate, by the radius, comma, theta. So now we're just going to practice how we plot points in a polar coordinate system. So I'm going to look at this graph right here, and we are going to plot 3 pi over 4. So what does this mean? This means that I'm going to use the circle that has the third radius. So 1, 2, and I'm just going to highlight it. You do not have to do this, but just visually on the video, hopefully it makes sense. There's my circle that has a radius of 3. And now so that's my directed distance, but my angle is pi over 4. Now the polar paper that I've provided for you goes in terms of 15 degrees or pi over 12 radians. Pi over 12, 2 pi over 12, 3 pi over 12, and so on. So pi over 4 is equivalent to 3 pi over 12 in radians. So I am looking at this angle. So when you put it together, the polar coordinate 3 pi over 4 lies right here. Here's my angle, that is pi over 4, and this is a distance of 3 units or 3 radii. Now let's graph 3 negative pi over 4. So what does not change is the circle. I'm still looking at that third concentric circle. Okay, so it kind of looks like a bullseye. Okay, but what has changed is that I'm at negative pi over 4. For those of you who need this, again, I know not all of you will need to convert to 12ths, but this is negative 3 pi over 12. So negative 1 pi, 2 pi, 3 pi. This is the axis that I'm dealing with, and where those meet is right here. Again, you don't have to highlight the green that I've highlighted. I'm just trying to visually show you this on a video. So this right here represents the point 3 negative pi over 4. The radius is on the third concentric circle, and my distance from the polar axis is negative pi over 4 radians. Now, what we have to discuss is problems like this, where I have a negative 3 pi over 4. I'm going to discuss the angle first because we have already talked about that. Pi over 4 is 3 pi over 12. So 1 pi over 12, 2 pi over 12, this is the pole or the angle that I'm looking at. However, a negative 3 denotes direction. When I had a positive 3 pi over 4, notice how I went from the polar axis and I went a positive 1, 2, 3. But now that it is negative, I go from the pole, and this right here is my angle, this entire, if you kind of think of this as an axis. And so pi over 4 got me to this diameter, for lack of a better word. And instead of going 3, 1, 2, 3, because of the negative, I have to go backward. 1, 2, 3. So this is where the point -3 pi over 4 lies. Last but not least, let's discuss -3 negative pi over 4. Okay, so what's going on here? Well, if I go to negative pi over 4, we know from the previous problem that it's located on this pole. Okay, so again, if you want to just think of this as a diameter, from the polar axis to this point, we've gone a distance of negative pi over 4. And had my radius been positive, then I would have gone 3 units directly on that ray. However, because it's a -3, I have to go a distance of 3 on this circle in the opposite direction of the ray. So 1, 2, right here would be the point -3 negative pi over 4. So this leads in to our first example. For example 1, we want you to plot the point given in polar coordinates, and then we're going to find 3 additional polar representations of the point, making sure that your angles are between -2 pi and 2 pi. Okay, here we go. That should be a theta, not a 0. My apologies. All right, so when I want to graph 3 pi over 4, if I locate 3 pi over 4 in twelfths, that is going to be 9 pi over 12. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the ray that I'm looking for. 2 is positive. So on this ray, I'm going to go out 1, 2, and there is my point plotted in a polar coordinate. Now, we need to represent this point using 3 additional polar representations. Well, one way to get to this point was to go in this direction, which was a distance of 3 pi over 4. Another way that I could do this is I could still keep the radius positive of 2, but I could get to this point by going in a clockwise direction. And this distance from 0 to this distance would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pi over 12, and 15 pi over 12 is divisible by 3, so I would get 5 pi over 4 in a negative direction. So another way to represent this exact same point is to -5 pi over 4. So I still have to come up with 2 additional ways to represent this point. Well, another way to do it is if I think of this pole right here, if I get to this part of the polar graph and then make it a -2, it'll bounce back. So this distance right here is -1, 2, 3. So -3 pi over 12, which is -pi over 4. So if I make my angle -pi over 4, but then not a radius of 2. If it was a radius of 2, my point would be right there. I need to get back to the opposite ray, so that would be -2. I can get to this same area by going in a counterclockwise direction. And so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That would be 21 pi over 12. Each of those are divisible by 3, so that would give me 7 pi over 4. But again, if I went to 7 pi over 4 and I need to get to this point right here, I need to kick it back, so that would be -2. So 2, 3 pi over 4 can also be expressed as 2 -5 pi over 4, where I go a negative angle and then I go 2 units on that ray. It can be represented as -2 -pi over 4, where I go a negative direction of -pi over 4, and then because of the -2, it kicks back to the opposite side of the pole. And then I can also go 7 pi over 4 in a positive direction, and for my angle theta, and then kick back on the radius -2. All right, let's talk about coordinate conversion, how we can convert from the rectangular coordinate system, and by rectangular we mean xy coordinates, to polar coordinates, which come in r theta, and how we can go backwards and forwards. All right, let's think about this for just a minute. Let's say that I give you the rectangular coordinate 3, 4. All right, now if we want to plot that, I'm going to go 3 units right, 4 units up, and plot. Well, this is one way to think about it, but another way to think about it is, couldn't I figure out what that angle is and then what my radius distance is in order for it to be polar? So the radius is equal to just a Pythagorean theorem problem. The radius squared is equal to 3 squared plus 4 squared. Most of you hopefully will see it's a Pythagorean triple, but we get 9 plus 16. R squared is equal to 25, and because we're dealing with distances, R is equal to 5. So now this rectangular coordinate becomes a polar coordinate where 5 is the radius. Now, in order to get the angle, there's several things that you could do at this point. You could actually take any of the trig functions, but if I think of SOHCAHTOA, and I was given that my x value was 3 and my y value is 4, TOA deals with the opposite over the adjacent. So I can consider the tangent of theta to be 4 over 3. And if I wanted to solve for theta, I could take an arctan or an inverse tan, however you want to write it, is theta. If you want to, you can plug that into your calculator, and I'm not going to right now just for the sake of time, but whatever the arctan of 4/3 is would be my angle theta. So the rectangular coordinate of 3/4 would convert to 5 arctan of 4/3. Now, what if we go the other way? Well, haven't we learned when we thought about the unit circle, and we're going to take the unit circle away in just a minute, but when we talked about the unit circle, weren't all of our points on the unit circle in terms of cosine, there's my phone again, I'm so sorry, of cosine, sine? Does that ring a bell? Cosine, sine? So my x on the unit circle is equal to the cosine, you know what, I'm going to switch my variables so we don't get confused. Let's talk about theta. Okay, is equal to cosine theta. Y is equal to sine theta. But what happens when I take away the unit circle, and as you saw from our polar paper, we can have radius or radii of all different lengths. Well, all you do is you take that x value or that y value and you multiply by the radius. Okay. So in coordinate conversion, the polar coordinates r theta are related to the rectangular coordinates xy as follows. Okay, so to sum everything up, x is equal to r cosine theta, where r represents the radius and theta is your directed angle. Y is equal to r sine theta. And then when you're going the opposite direction, as we did up here, you need to know that r squared is equal to x squared plus y squared, and that the tangent of theta is equal to your y over x. And that's the information that you need in order to do coordinate conversion. Here we are at example 2. We're going to plot the point given in polar coordinates and find the corresponding rectangular coordinates for the points. And I'm going to give you -3, -2 pi over 3. All right, so let's first graph it, and I'll graph it on this polar paper. And I'm just going to highlight the poles or the axes so that we're clear on where we're at. So -2 pi over 3, I can convert that to 12ths. So 3 times 4 is 12, so it's -8 pi over 12. So -1, 2, 3, 4, 5, 6, 7, 8. This is what I'm dealing with. And because I have a -3, I am not going to put my point here on that ray. I've got to jump to the other side. So I actually have a first quadrant point. So this right here is the point -3, -2 pi over 3. Now what we want to do is get the corresponding rectangular coordinates for that point. Well, I know that x is equal to r cosine theta. So that means x is equal to the radius of -3 times the cosine of -2 pi over 3. Well, negative 2 pi over 3 on a unit circle, and I know this isn't the unit circle, but it just gives us a point of reference, is going to be a short x, long y. Short x, long y. The cosine is the x coordinate, so I take negative 3 times negative 1/2, and x is equal to positive 3/2. And that hopefully will make sense to you because my coordinates, my rectangular coordinates should be positive, positive to be in the first quadrant. Now, in order to find my y value, y is equal to r sine of theta. So y is equal to negative 3 times the sine of negative 2 pi over 3. The sine is the y coordinate. So I'm going to take y is equal to negative 3 times negative root 3 over 2. And so the negatives cancel, and so my y value is going to be positive 3 root 3 over 2. So negative 3, negative 2 root 3 in polar coordinates converts to rectangular coordinates as 3/2, 3 root 3 over 2, which also lies in the first quadrant. Okay, for example 3, we're going to use a graphing calculator to find the rectangular coordinates for the point given in polar coordinates. So I just want to do this by hand first. I know the directions want me to use a graphing calculator, but this way, when we use the graphing calculator, we can kind of verify our results and you can see how it works. So if I want to put this in rectangular coordinates, I have x is equal to r cosine theta. So x is equal to negative 2 times the cosine of 7 pi over 6. And if I think about where 7 pi over 6 is on the unit circle, I have a long x, short y. So the point there is negative root 3 over 2 comma negative 1/2. So x is equal to negative 2. The cosine of negative 7 pi over 6 is negative root 3 over 2. And so when I multiply those together, the 2's cancel, so my x coordinate is root 3. When I want to find the y is equal to r sine of theta. So y is equal to negative 2, the sine of 7 pi over 6. The sine of 7 pi over 6 is negative 1/2, and so I get 1. So negative 2, 7 pi over 6 in polar coordinates is equivalent to root 3 over 1 in rectangular coordinates. So polar, rectangular. So please keep this in mind. Now I'm going to switch to the calculator and show you how the calculator can convert polar to rectangular and how it can convert rectangular to polar. All right, so this is how you use your calculator to convert polar coordinates to rectangular back and forth. I'm just going to add a calculator page. And what I'm going to go to is I'm going to go to the book or the catalog, and I'm going to hit polar. All right, so I'm going to push P. It's going to go down to polar. And do you see how it has two choices here? P and then the arrow, RX, and then the cursor. This is saying take a polar coordinates and convert it to the x coordinate of a rectangular. And then this is the command P equals, that's going to convert it to a rectangular and give you the y coordinate. And down here it tells you that you pull up this command and then you put in the r value, comma, the theta value. So I'm going to go ahead and do P equals Rx. Okay, and I need to put in, so we're converting polar to rectangular. My polar radius was negative 2. I'm going to put a comma, and then my theta was 7 pi divided by 6. And when I push enter, it gives me 1.73205, and we got root 3 as our answer, and if you calculate root 3, it is also equal to 1.73205. So that converted it that direction. Now if I go back to the catalog and I pull up the y coordinates, and again I type in negative 2 comma 7 pi divided by 6, then it gives me 1, which we converted into the y coordinates. Now, if I want to go backwards, if I want to take the rectangular and put it into polar, then if I go to the catalog and I hit R, okay, notice how alphabetically I get R arrow P theta, where you're going to take a rectangular coordinates, and this is going to calculate theta r equals, or the arrow PR is going to calculate the r coordinate. So let's do the r coordinate first, since that's how coordinates go. And I need to type in root 3, which was my x coordinate, arrow that out, comma 1. And it gave me 2, which is the radius. Now notice, we're going to talk about this in just a minute. 2 wasn't, we didn't get -2, but let's talk about what the calculator is giving to us momentarily. All right, and then I've got, pull up the command, the rectangular coordinate, and it's going to calculate theta for us. Again, root 3. And we got 0.523599, which again is in decimal form. Let me talk about what's happening, how we're getting the 0.523599. So the calculator gave us 2, 0.52. Why? Well, if I graph the point, -2, 7 pi over 6, 7 pi over 6 converts to 14 pi over 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is where 7 pi over 6 is located. And I had a -2 as a radius. So that means it's going to pop to the second concentric circle here. So here's my point. So notice that what the calculator gave us was, it did give us 2, and 0.52 is going to be 2 pi over 12, which is pi over 6. So if you verify pi over 6, and think about it, pi is approximately 3.14. It should make sense that 3.14 divided by 6 is pretty close to a half. So the calculator gave us a different representation of that point. So hopefully you understand how to use the calculator to go back and forth, understanding that when we try to convert root 3.1, it didn't give us back our original. It gave us back the original place, but it gave it to us in a different representation. And here's our last example on this particular video. We're going to plot the point given in rectangular coordinates, and we're going to find 2 sets of polar coordinates for the point 0 is less than or equal to theta is less than 2 pi. So this is a rectangular coordinate. So I am just going to use a little bit of margin here and plot root 3, which is between 1 and 2, -1. So there is my point in rectangular coordinates. And now we have to find 2 sets of polar coordinates for that point. Well, in order to do that, if I drop a distance and then go up, I've created a right triangle where my x value is root 3 and my y value is -1. So if I do Pythagorean theorem, I will figure out r. So I can take root 3 squared plus -1 squared equals r squared, which is 3 plus 1, which is 4. And because we only deal with positive distances, my r is 2. So in rectangular, I have root 3 -1, but as a polar coordinate, I know that my radius is 2. So I already know, let's kind of highlight there's the vertical, that is the horizontal. So I know I'm dealing with the second concentric circle. Okay. Now I need to find the angle. So in order to find the angle, well, I know this is the angle theta. I'm sorry, this is kind of small that I need to find. So I know that the tangent of theta is equal to my y over my x coordinates. So -1 over root 3. So thinking back to your unit circle, you have to find an angle that when we take its y over its x coordinate, we get -1 over root 3. So if I think about the point here, here, and here, so this is right here, this is -pi over 6, this is -pi over 4, this is -pi over 3. -pi over 6 has a long x, short y. We know it's not -pi over 4 because that would be -1. It's root 2 over 2, root 2 over 2. And -pi over 3 has a short x, but a long y. So which y over x yields -1 over root 3? It's right here at -pi over 6. So 2 -pi over 6 is one way to talk about this coordinate. However, the direction stated that we want all thetas between 0 and 2 pi. -pi over 6 is not between 0 and 2 pi. So how do we get this point right here? Well, I could get it one way by, instead of going at a negative angle, I could go at a positive angle. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. If I do 22 pi over 12, this gives me 11 pi over 6. So 11 pi over 6 is one of my answers. Okay, but then the other, I still need an angle between 0 and 2 pi. I still need to go in a positive direction. Well, if this was where negative pi over 6 was at, then I could keep going to the other side, and I could get to this pole. So I can go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi over 12 reduces to 5 pi over 6. However, I wouldn't want my 2 on that pole. I need to drop it back to this side, so it would be a negative 2. So my final answers are 2, 11 pi over 6, and negative 2, 5 pi over 6. You are now ready to try page 680, numbers 1 to 37 odd. Good luck.